Now let's count some slices. Over here, how many quarters are there in a half? Well, there's 1, 2 quarters in a half. Look at this right here. How many thirds are there in 3 whole parts? 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 thirds in 3 whole parts. Now this one's a little bit harder to see, but let's give it a try. This is divided into 8 parts. How many eighths are there in 3 quarters? So this is 3 quarters of the rectangle right here. So there's 1, 2, 3, 4, 5, 6. There's 6 eighths in 3 quarters. Now we can actually represent mathematically everything what I just said as follows. Now the graphs we just had can be replaced like this. If you have a half divided into fourths, you have 2 slices. 3 whole parts divided into thirds is 9 pieces. 3 quarters divided into eighths, you have 6 little pieces. Now, we get these results because we had the pictures. Well, now let's actually mathematically figure out a method to do this division. The reciprocal of a fraction is a fraction where the numerator and denominator swap places. This swapping is called inverting a fraction. For example 29, I want to find a reciprocal of a series of numbers. For the first one here, well, just switch places. So put a 3 on top, 2 on the bottom. That's the reciprocal of 2/3. 5, what's the numerator and what's the denominator? Well, to make things clear, let's put this over 1. So now it's obvious. Just switch it around. You're going to get 1/5. What is the reciprocal of 0? Well, put 0 over 1 like we do with the 5. So the answer would be 1 over 0, right? No. We cannot divide by 0. So 1 over 0 is not even allowed. So the answer here is undefined. And for this last one, we need to change our mixed number to an improper fraction. So we're going to multiply and then add. So 4 times 5 is 20, plus 2, you're going to get 22. The denominator stays the same. So if you switch this around, we're going to get 5 over 22. To divide fractions, invert, find a reciprocal, of the second fraction, then multiply, cross-cancel, the fractions together. If mixed numbers are involved, change them to improper fractions. Place whole numbers over 1. Now going back to our original divisions that we had based on those graphs, let's see what we can do. So for the first one here, it's going to be 1/2 times, invert the 1/4, you're going to get 4 over 1. Let's do some canceling here. So my answer is going to be 1 times 2 is 2, 1 times 1 is 1, so I get 2. Over here, place whole numbers over 1. So I'm going to get 3 over 1 times 3 over 1. Deja vu. And then, nothing cross-cancels, so we just multiply straight through. We're going to get 9 over 1, so the answer is 9. And over here, let's just write down the 3/4 times 8 over 1. Does anything here cross-cancel? Yes. So the 4s and the 8s, they have a 4 in common. We get 2 and 1. So this is going to give us 6 over 1, which is 6. Which is where the answers we got originally. Now let's divide some more fractions. Over here, let's invert and multiply. So I have 3/8 times 12/5. And let's do some cross-canceling here. There's a 4 in 8 and 12, so we're left with 3 on top and a 2 on the bottom. Let's multiply these straight across. You're left with 9 tenths. Let's do another one. Now let's divide a couple of mixed numbers. Of course, the first step is you need to change them to improper fractions. So let's do that. 1 times 3 is 3, plus 1 is 4 thirds, divided by, and over here you're going to get 5 times 5 is 25, plus 2 is 27. The 5 stays on the bottom. Okay, now, very special warning right here. A lot of people at this point want to start canceling stuff. Hey, that's 3 and 27. You go, don't go there. Okay? Don't do this. Why? Well, it's not set up for multiplication yet. See, this is still a division. So I need to follow the rules of inverting and multiplying. So I'm going to get 4 thirds times, and then flip this around to get 5 27ths. Alright, now we try to cross cancel. Well, nothing cancel. So just multiply straight through. So I'm going to get 20 over 81. To convert complex fractions to simple fractions, or divide them, just change the main fraction bar, the widest one, into a division symbol. Then proceed as before. Let's simplify this complex fraction. So notice this is the widest fraction bar, so that's going to become our division symbol. This is equal to 2 thirds divided by 5. And then to divide this, again, the first step is put that over 1. Then we invert and multiply. So we're going to get 2 thirds times 1/5. And nothing can be canceled, so we're just going to get 2 15ths. For example 32, let's divide some fractions, if possible. So, the main fraction bar becomes a division symbol. So this becomes 3/8 divided by 11/12. Now, don't cancel stuff yet. We invert and multiply. 3/8 times 12/11. Now we can zap stuff out. Zap, zap. So I have a 2 left over, and I'm going to have a 3 left over on top. Now let's multiply these together. So I'm going to get 9 over 22. And what about this one over here? Well, 0 divided by any number. There's a rule for that. How do you memorize it? It's just 0. So that's an easy problem. And what about this over here? Well, a rule says that if you have a number that's divided by 0, it's undefined. You don't have an answer. That's it. Now to divide on the calculator, it's pretty much the same thing as multiplication. Just invert and multiply. But there's something you need to remember. Use your parentheses. For exercise 35, I'd like you to find the reciprocals of these numbers. So all we got to do is just flip them around. It's easy. So this really just becomes 9 halves. Right? Easy. This one, just flip it, and we're going to get 8 over 1. But for this one, we'll go one step further, because I can simplify that to just 8. And then let's just switch this one around. And we're done. Okay, we're not really done. I was just messing with you here. We can't do that with this. So let's change this to an improper. So I'm going to times it and then add it to the top. So we're going to get 4 times 5 is 20 plus 3 is 23. And the bottom stays the same. Let's flip this. So we're going to get 5 over 23. And that is the actual reciprocal. For exercise 36, I'd like you to perform the following operation. So, for the first one, I'm going to change this into a multiplication. So I'm going to have 5 times 16 15ths. And let's just put that over 1. Things can cancel nicely. So multiply that out, and we're going to get 16 thirds. Over here, I'm going to rewrite this to get 4 divided by 3 sevenths. Again, let's put the 4 over the 1 and invert and multiply. So you get 4 over 1 times 7 thirds equals, well, nothing cancels, so we're just going to be left with 28 thirds. And I'll go ahead and try this one right here. Well, we need to do some rewriting. So this becomes 14 27ths divided by, because again the main fraction part becomes a division symbol, 7 15ths. And what? We need to invert and multiply. 14 27ths times 15 sevenths equals. Well, what can we cancel from this? Well, the 7 and the 14, we can zap some stuff out. Hey, there's a 3 in here. So then we put that together, and we're going to get 2 times 5 is 10, 9 times 1 is 9. And we're done.